So we're in lesson AMU1 L7. This is quadratic equations, solving them. This particular lesson covers a lot of ground, and it covers it quickly because it assumes, since this is advanced math, that this is a review for you. So if you find a spot in here that is more difficult than what you can handle, just let me know and I can remediate that. Now, we're going to look at 3 different ways to solve quadratic equations using the zero product property, using the square root property. Now we're going to look at something called completing the square, which is a technique to set up for the square root property. And then we're going to look at the quadratic formula, which, as we all know, is the sledgehammer. It always works. Now, when you're asked to solve a quadratic equation, they could tell you to solve it, find the roots, or find the zeros. All of those mean just find the answer. Because we know what happens when you graph a quadratic equation. Well, you're going to get a parabola. So what are we looking for? We're looking for the 2 places where that parabola crosses the x-axis. So that's our goal, is to find that. All right, let's get started. So the first method we're going to look at is using the zero product property, and that's where you factor. Now, we learned all about factoring, or we reviewed factoring in lesson 2 of this unit, so if you need to flip back through that, go ahead. The zero product property is based on the fact that if you have A times B, if you have 2 things multiplied together and it's equal to 0, your product is 0, then one of those things has to be equal to 0, if not both. They both could be, but at least one of them has to be equal to 0. Well, before you can use the zero product property, you have to have a product, and that means you have to have 2 things multiplied together, which are factors. How do you get factors? By factoring. So here we are again. We've got this trinomial. Now, before you can use the zero product property, you do have to have a 0 over here. This equation is already in the proper format. So we're just going to head right on into factoring. We see that we have no greatest common factor. We count our terms, 1, 2, 3. We know that when we have a trinomial, the option is, do I unfold or do I use the AC method? Now, there are other methods, but those are the ones that I've used. So, since there is no coefficient in front of this, it's a simple unfolding. We know it's going to be a set of parentheses. Since there's no coefficient, we know it's going to start with y in both places. Since this is a minus sign, that tells us that you're going to have one of each sign. Now, we need 2 numbers here that multiply to give us negative 30 and add up to give us negative 13. So you can make a chart, or it may just hit you that negative 15 and positive 2 is going to suit the bill there. All right, now that we have factors equal to 0, you take each factor. So y plus 2 equals 0, or y minus 15 equals 0. And we're just going to solve. Subtract 2 from each side. So either y is equal to negative 2, or add 15 to each side, y is equal to 15. Negative 2, 15. Okay. Example problem number 2 says 2x squared plus 6x is equal to 80. So this one is not in the proper format. I need to get a 0 here. So I'm just going to subtract 80 from each side, and that's going to give me 2x squared plus 6x minus 80 is 0. And now I'm ready to factor. As always, look for a greatest common factor first. I see that 2 will go into all of these things. So now I have this. Is the 2 important now? Well, yes it is. We don't want to lose it, but you know, our point here is to find out what can be 0. 2 is never going to be 0, so I don't need it for the rest of my zero product property. But now I need to factor this. Once again, I've already gotten the greatest common factor, so now I count my terms. There's 3. I either unfold or AC method. Since I do not have a coefficient, I'm going to unfold. So that's going to give me 2 sets of parentheses, x and x. Since this is a minus sign, I'm going to have one of each sign. Now, I need a pair of numbers that will multiply to give me negative 40 and add up to give me positive 3. So that's going to be positive 8, negative 5. And just like with the other one, I'll take each factor and set it equal to 0 and solve. So this is going to give me x is negative 8, x is positive 5, and there are my two solutions. Problem number 3, 4w squared minus 10w, and I've been told to solve it using the zero product property. So I'm going to need a 0 here. So first let me add 10w to each side. And that's going to give me 4w squared plus 10w equals 0. Now I factor, because that's how you do the zero product property. What's the greatest common factor between these two first off? Well, 2w will go into both of those, and that will leave me 2w plus 5 is equal to 0. Now, neither one of these has any more exponents, so there's no more factoring to be done. These are my two factors. So I'm going to take 2w and set that equal to 0, and I'm going to take 2w plus 5 and set that equal to 0. Now I'm going to solve both of them. Here, I'll divide both sides by 2, so w is 0. Here, I'm going to subtract 5, so I get 2w equals negative 5, and then I'm going to divide by 2, so w equals negative 5 halves. So my options are 0 and negative 5 halves. And number 4 says 5p squared equals 4 plus p. So the first thing we need to do is get a 0 here. So we're going to subtract 4 and p from both sides. Now when I put it over here, I'm going to put it in standard form. So I'm going to put the 4 at the end. I'm going to rewrite this as 5p squared minus p minus 4 equals 0. Now I'm ready to factor. There is no greatest common factor, so I'm going to have to factor this with the AC method. If you remember the AC method, you multiply a times c, which is 5 times negative 4. It's going to be negative 20. I need a pair of numbers that will multiply to give me negative 20, but add up to give me the coefficient here, which is 1. Now remember, the goal behind the AC method is to split this middle term into 2 terms so that we have a 4-term polynomial, and then we can factor by grouping. All right, the pair that's going to multiply to give me negative 20 but add up to give me negative 1 is negative 5 times 4. So I'm going to rewrite this as 5p squared minus 5p plus 4p minus 4. Okay, and then this is equal to 0. I will factor by grouping. The greatest common factor here is 5p, so that's going to leave me p minus 1. My greatest common factor here is 4, so that's going to leave me p minus 1. All right, the p minus 1 becomes my greatest common factor here, and I'm going to be left with 5p plus 4. So now I take each factor and set it equal to 0. P minus 1 is 0. 5p plus 4 is 0. And we're going to solve. Add 1 to each side. So p could be equal to 1. Subtract 4 from each side and then divide by 5. So that's going to be 5p is negative 4. Divide by 5. So my possibles there are negative 4/5 and 1. In this section, we're going to be using the square root property. Now, the square root property simply says you can take the square root of both sides of an equation. It's perfectly fine. You'll get the right answer. So, we're going to look at this equation 2 different ways. First, I'm going to take this. Now, before you use the square root property, you want to have a single perfect square on one side or the other. So I'm going to move 81 to the other side. That's going to give me 16d to the second is equal to 81. Now the square root property says you can take the square root of both sides of an equation. Now when you take the square root, you're going to need to add that positive negative sign on the right-hand side. All right, what is the square root of 16d squared? 4d equals plus or minus 9. And then we're going to divide both sides by 4. So d is equal to positive negative 9/4. Okay, that would be your answer. But I just want to show you, what if you had done it a little bit differently? Would you still get the same answer? Now, to use the square root property, we're still going to add the 81 to each side. But once we get it in that format, what if I decided to divide both sides by 16 first, so that I get d squared is equal to 81 over 16. That's fine. Now let's take the square root of each side, and this will be plus or minus over here. The square root of d is d. Got plus or minus. What's the square root of 81? 9. And the square root of 16 is 4. So even though I did the steps a little bit differently, you can see where I took the square root from each side, you still get the same answer if you just, stick with the rules in math that you know. All right, let's look at the next one. Okay, number 6 says negative 6m squared is equal to 48. We're told to use the square root property. So let's first get rid of the negative 6 because we just want a perfect square all by itself over here. It's been multiplied, so I'm going to divide, and that's going to give me m squared is equal to negative 8. Now that I have a single perfect square over here, I'm going to take the square root of that and the square root of plus or minus over here. So now I have m equals plus or minus square root of negative 8. So let's recall our tools for simplifying a radical. Now what happens when you have a negative under there is the negative becomes I squared. So when you take the square root of that out, that's just going to be an I. All right, so we took care of the negative by pulling that out. What's a perfect square that will go into 8? Well, I could factor that as 4 times 2, right? What's the square root of 4? Just a 2. And then this 2 has to stay under there. So that's going to be your answer. Okay, number 7 is 3/2 x squared plus 11 equals 59. Before I can use the square root property, I want the only thing left over here to be my perfect square. So first I've got to get rid of the 11. I'm going to subtract 11 from each side. So now I have 3/2 x equals 48. Now I need to get rid of this fractional coefficient. How would you normally do that? Well, you're undoing what's been done. Quickest way to do it is multiply by the reciprocal, actually. In essence, what you've got to do is, since this is divided by 2 and multiplied by 3, you've got to do the opposite, which means if you multiply this by 2/3, what happens? Whatever you do over here, you've got to do over here. That was an x squared. So now I have x squared equals 48 times 2 is 96, and then 96 divided by 3 is 32. So x squared is equal to 32. Now we're going to take the square root of each side, remembering that plus or minus. If you insert the square root, you have to put the plus or minus. All right, this will be x. Now, the square root of 32, what is a perfect square that will go into 32? 16 times 2, huh? So then we'll pull the square root of 16 out. That gives us 4, square root of 2. Okay, number 8, we want to solve this using the square root property. So we're going to try to keep the s squared over here all by itself and get rid of everything else. Now the 10, you look in front of it to find what's been done. It's positive, so it's been added. So I'm going to subtract 10 from each side. That gives me negative 7s squared is equal to negative 9. Now I'm going to divide both sides by negative 7. So this gives me s squared is equal to negative over negative is positive, 9 over 7. Okay, now we're going to take the square root of each side. This looks pretty simple. Don't forget your plus or minus. So I have s is equal to plus or minus square root of 9 over 7. All right, now we need to simplify. What is the square root, and let me bring this over here so I'll have a little more room. What is the square root of 9? Well, that's just 3, but then you have that square root of 7 on the bottom, and we know you need to rationalize that denominator. So how do you do that? You're going to multiply by square root of 7 over square root of 7. So we're going to have s is equal to plus or minus. All right, this is 3 times square root of 7 on the top, and square root of 7 times square root of 7 gives you square root of 49, which is just 7. Now before we head into the completing the square section, I want to explain. Completing the square isn't in and of itself the way to solve the problem. What you do is you complete the square, and then you're going to use the square root property like we just did. You're going to wind up with a problem that looks like this. So before we start getting this, let's look at what's going to happen when you put the square root property on this. I do have a perfect square here, even though it's a binomial. The whole thing is a perfect square. So if I take the square root of that and the square root of the other side, let's see what happens. When you take the square root of a square, they cancel out. So now I have x plus 5 equals, plus or minus, the square root of 49 is 7. And then I would just solve it. I'm going to subtract 5 from each side. So now I have x equals negative 5 plus or minus 7. All right, this is actually 2 answers because I have x equals negative 5 plus 7 and x equals negative 5 minus 7. So this would be x is equal to 2 or x is equal to negative 12. There's my 2 answers. So the square root property works really good in this situation. So how do I get that situation? Well, where does a binomial squared come from? We learned a long time ago about something called a perfect square trinomial. And what I want to do, let me just take x plus 3 and square it. And we're going to expand that out. Remember, you don't just square each thing. So what happens if I distribute or use the full method on this? I get x squared plus, all right, 3x plus 3x is going to give you 6x, and then 3 times 3 is 9. This is a perfect square trinomial, and it fits a pattern. And the pattern was that if you had a perfect square on either end and a plus sign here, and then if this was equal to 2 times the square root of your first and last term, so that would be 2 times x times 3, which it does, then that's a perfect square trinomial. Well, this came from this. So if I started with a trinomial that's a perfect square trinomial, I could just automatically go to the binomial squared, which is a perfect setup for the square root property. Well, if you don't have a perfect square trinomial, but you create one, that's what completing the square is. So let's look at how to take some numbers and make it into a perfect square trinomial. Okay, so let's just dive into one. Number 9 says y squared plus 12y plus 20, and we want to complete the square and then use the square root property. This is how it's done. First, we're going to move the constant term over to the other side by subtracting 20 from each side. So now I have y squared plus 12y equals negative 20. And I left a gap here because now I'm going to fill in the number that completes the square or makes a perfect square trinomial. Now, remember, as far as the formula went, the middle term had to be equal to 2 times the square root of the first term times the square root of the last. So I need to find a number that when I take the, when I multiply 2 times y times the square root of it, I get 12. Well, there's actually a little formula, b over 2 squared. All right, so what's b? Well, b is the coefficient of this middle term. So if I do 12 over 2 and square it, that's 6 squared, which is 36. So what I'm going to do is I'm going to add 36 here. This makes a perfect square trinomial. But you cannot just add 36 to one side. You have to add 36 to both sides. So now what we have, since this is a perfect square trinomial, it will factor into y plus 6 squared. And you could unfold it if you want to. You're going to get y plus 6 times y plus 6. And then you make it into y plus 6 squared. All right, down here, I wind up with 16. And this is all of the completing the square. Now we're back to the square root property like I just showed you. So the square root of this is going to be y plus 6. Now remember, since I took the square root, I've got to do the plus or minus sign. All right, what's the square root of 16? 4. So if I do minus 6 from each side, that's going to give me y is equal to negative 6 plus or minus 4. All right, let's come over here. So if I do negative 6 plus 4 and negative 6 minus 4, that's going to give me my two answers. This would be negative 2. This is negative 10. Okay, let's look at another one. This makes more sense when you start to see a pattern. Okay, so number 10 says 7b squared plus 14b minus 25 equals negative 4. Now before we can use the square root property after completing the square, we need a coefficient of 1 in our front of our first term, and we need to move this to the other side. So first we're going to add 25 to each side, and that's going to give us 7b squared plus 14b equals negative 4 plus 25 is 21. Now to get a coefficient of 1 here, we're just going to divide all the way through by 7. So now I have b squared plus 2b equals 3. Let me leave a space. Okay, now right here, I'm going to complete the square by using this formula. B is the coefficient of my middle term. So I've got 2 over 2 squared, which is 1 squared, so that's just 1. Whatever I do to this side, I have to do to the other. So now I have b squared plus 2b plus 1 equals 4. All right, since I completed the square, I created a perfect square trinomial. And this will factor into b plus 1 squared. I just used my formula. Square root of the first term, square root of the second term, all squared. So that's where I got that. And then equals 4 here. Now I'm ready to use the square root property. So I'm going to take the square root of each side with my plus or minus. All right, the square root of b plus 1 is just b plus 1. And the square root of 4 is plus or minus 2. So when I subtract 1 from each side, I'm going to have b is equal to negative 1 plus or minus 2. So negative 1 plus 2, negative 1 minus 2. All right, negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. So there's your answers. Okay, number 11, v squared minus 13v plus 8 is equal to negative 4. At least we already have the 1 for a coefficient. So I'm going to subtract 8 from each side, and that's going to give me v squared minus 13v equals negative 12. All right, to find out what goes here, I'm going to use this formula. My b is 13. So I've got 13, and you don't have to worry about whether it's negative or positive. In order to make a perfect square trinomial, this has to be a plus sign. So now I'm going to have 13 over 2 squared. Now let me tell you a trick. There's no need to square this right now here. I'm going to have 13, all right, but I am going to want to go ahead and square it when I add it to this side. So that would be 169 over 4. Okay, now when I do the perfect square trinomial formula, since this is a minus, I'm going to have v minus 13 over 2 all squared equals, and I'm not trying to prove anything, so I'm just going to put this in the calculator real quick, and that is going to give me 121 over 4. Okay. Now I'm at the beautiful point to use the square root property. I have a perfect square over here, and I'm going to take the square root over here, plus or minus. Now, this square root cancels out. So I have v minus 13 over 2 equals plus or minus. All right, the square root of 121 is 11, and the square root of 4 is 2. So I'm going to add 13 halves to each side, and that's going to give me, let me come over here. So now I have v equals 13 halves plus or minus 11 halves, all right? And once again, when you simplify 13 over 2 plus 11 over 2 and 13 over 2 minus 11 over 2, that's going to give me 24 over 2, which is 12 here, and 13 minus 11 is 2 over 2, which is 1. So your two answers are 12 and 1. Okay, here's our last completing the square problem, and this is number 12. We've got 4a squared minus 20a plus 44 equals negative 5. So the first thing we want to do is move that 44 by subtracting it from both sides. So what I have here is 4a squared minus 20a equals negative 49. Now I need to get rid of this coefficient. So I'm going to divide all the way through by 4. All right, that leaves me a squared minus 20 divided by 4 is 5a equals, and I'm just going to leave this negative 49 over 4 for right now. All right, now right here I need to put the number that completes the square, that creates a perfect square trinomial. So that's going to be a plus sign, and then I'm going to use my formula. B is the coefficient of this term, and you don't worry about whether it's positive or negative because this has to be positive. So I'm going to have 5 over 2 squared, which is going to be 25 over 4, okay? Now over here, I'm going to just write that as 5 over 2 squared, because to use the formula I got to take the square root of it anyway. But over here I'm going to go ahead and put the simplified version of it. Okay, now to factor this perfect square trinomial, I'm going to use the square root of the first term. Since this is a minus, it's going to be minus square root of this, all squared. All right, over here, negative 49, since they're both got the same denominator, we can just go ahead and subtract. So that's going to be negative 9 minus 5 is 4, 24 over 4, which is negative 6. Let's go ahead and do that. Okay, now we're going to take the square root of each side, plus or minus. So the square root of this is a minus 5 halves equals plus or minus square root of negative 6. We're going to add 5 halves to each side. So now I have a is equal to 5 halves plus or minus the square root of negative 6. Okay, and the only thing to do here is get this negative out. So let's come back up here. I am simplifying 5 halves plus or minus the square root of negative 6. Remember, when you have a negative under the radical, your powers of I let you pull the I out and leave the 6 under there. And you don't, since you're not going to be able to combine the terms, you don't have to split these into 5 over 2 plus that and 5 over 2 minus it. You can just leave it just like that. Okay, our next two problems are using the quadratic formula. So before you can use it, you have to get this in standard form. I know y'all have all worked quadratic formula problems before, so we'll just kind of go through this quickly. We are going to subtract 10k from each side. Putting this in standard form, I need the 10k in the center, in the middle, second term, and 0. Okay, here is A, here is B, and here is C to plug it in. So I have x equals, all right, negative B is going to be positive 10, plus or minus. And b squared, negative 10 squared, is 100 minus. All right, 4 times a times c is going to be 4 times, my a is negative 1, my c is negative 8, and this is all over 2 times a, which is negative 1, okay? So let's see what all we can simplify here. All right, looking at this, negative 1 times negative 8 is going to be positive, and 4 times 8 is 32, and 100 minus 32 is going to be square root of 68. And then 2 times negative 1 is negative 2. All right, let's simplify this just a little bit more before we split it. What's a perfect square that will go into 68? Well, 4 will. So I could rewrite this as 4 times 17 over negative 2. And then I'm going to bring this up here. So I've got 10 plus or minus. All right, the square root of 4 comes out. So I have 2 square root of 17 over negative 2. All right, when your denominator will go into both terms above it, or all the terms, you can just cancel out. So negative 2 will go into 10 negative 5 times. And negative 2 will go into positive 2 negative 1 times. So let's be careful with all these signs. What I actually have at this point is, okay, so I'm going to split it because I want you to see what's going to happen to these signs. Negative 5 plus negative 1 square root of 17, and negative 5 minus negative 1 square root of 17. So I don't really need the 1. Plus a negative is just minus. And here, minus a negative makes positive. So I have negative 5 plus square root of 17. So yes, I could put them back together if I wanted to, just like that. Okay, number 14 is 6x squared equals 3x minus 9. So let's get it all in standard form first. We're going to subtract 3x and add 9 from each side, or to each side. So standard form is going to be 6x minus 3x plus 9 equals 0. So here's your A, your B, and your C. So let's fill in. X is equal to negative b. Well, b is negative, so negative of a negative is going to be positive. Plus or minus. Okay, the square root of b squared, or once again, when you take negative 3 and you square it, that's going to be positive 9. Minus 4 times, all right, our A is 6 and our C is 9. So this is all over 2 times A. A was 6, so it's all over 12. Okay, let's simplify this stuff in the radical now. So when I multiply 4 times 6, that's 24, times 9, that's going to give me 216. And 9 minus 216 is going to be negative 207. Okay, all over 12. So let's see, is there a perfect square that will go into 207? And I'm going to come up here for this. So now I have x equals 3 plus or minus. All right, what perfect square will go into 207? Actually, 9 will. That will factor into negative 9 times 23 all over 12. Okay? Now, what do you do for the square root of 9? We're going to pull it out. And the square root of 9 is 3. But what's the square root of a negative sign? I. Square root of 23 all over 12. And once again, when you have the plus or minus sign, if your denominator will reduce by both factors or by both terms, you can just reduce it. So 3 will go into 12 4 times, and 3 will go into 12 4 times. So now we have 1 plus or minus I square root of 23 all over 4. Okay, here's our last problem, number 15, and this is a word problem. There was a rocket that was launched upward with an initial speed of 325 feet per second, and the path is modeled by h is equal to negative 16t squared plus 325t, where h is the height and t is the time. Now it wants us to tell us how long did it take the rocket to reach the ground. So you have to understand, you know, a rocket leaving the ground, going into the air and then going back to the ground, that is a parabola. So that's what quadratic equations tell you. All we have to do is apply, let's use the quadratic formula since I still have it up here. Now we're going to take this formula. I want to know when h, which is my height, is 0. So I'm going to substitute a 0 in for the height, and then 325t. Now I'm going to get it into standard form, which you can just reflect it if you want to. You really don't even have to do that. Equals 0. So we need an A, we have a B. What about C? What is C? Well, when it's missing, you can always insert a 0. So our C is going to be 0. Now when we fill this into the quadratic formula, we're going to have x equals negative B, all right, negative 325 plus or minus, all right, the square root of b squared is 325 squared. So I'm just going to put that, and minus 4 times, all right, A was negative 16, and what was C? It was 0, all over 2 times A, which was negative 16. Okay? So now, let's simplify. Right here, 4 times negative 16 times 0 is just 0. So we just eliminated all of that. The square root of 325, 325 squared is 325. So what I have right now is negative 325 plus or minus 325 all over negative 32. All right, simplifying this down a little bit more, negative 325 plus positive 325 is 0 over 32, which is just 0. Negative 325 minus 325 is negative over negative 32, which if you put that in your calculator, you're going to get a positive 20.3 seconds. So you get two answers. Here is 0, and here is 20.3 seconds. Now the problem asks us how long before it returns to the ground. So the answer we want is the returning one, 20.3. That's all.